Hi students, good morning. How are you? I hope you are all fine, right? Okay, maybe waiting for the next session to start. Okay, children, let's start with our session about the transformation of matter. This is a new chapter in chemistry. That is what transformation of matter. Matter is going to be transformed from one form to another, right? So, how this transformation of matter takes place, let us see in this chapter. Okay, children, let's start learning. And this. Now let us see about the matter and changes. Matter and changes. Transformation in the sense what, children? Change. Okay. It is going to transfer from one form to another form in the sense it is going to change from one state to another state. Am I right? That's what matter and change. I am going to make it simplified for you. Okay. Now let's see. Classification of matter. How this matter has been classified, maybe we have learned in the previous sessions while we are learning about the separation of the substances. We have seen that what has been matter classified into. What do you mean by matter and how is matter classified? This is what we are going to discuss. First of all, for matter. Matter is made up of so many subatomic particles, means so many particles, isn't it? What do you mean by matter exactly? Matter is having some space and it occupies, isn't it? And then how the matter has been classified, that matter will be classified into either solid, liquid and gas and all these things. We will get a review about the matter first of all, then we will get back to the transformation of it. Okay, children? So, let's look at the criteria of the classification of matter. We are going to classify the matter based on the different properties, like on the different properties we are going to make it classify on, and then this on the basis of the state, that is what the solid state, liquid state or the gaseous state, and even it can be classified on the based on the composition of the matter also. Means we have taken three different things to classify the matter, children. To classify the matter we have taken the so many different things, like three different things. That is what the properties, what are the properties of matter. Okay, based on the properties of matter, we are going to classify the matter. Again, we are going to classify the matter on based on the state of it. Okay, either it is a solid state or the liquid state or the gaseous state. In that state of the matter, we are going to classify into. And then we are going to classify that matter on the based on the composition, based on the composition. Okay, so based on the composition of matter also we are going to. Now let's see for the next. So properties, what are we going to discuss the properties for? That properties are based, that those are considered as intensive properties or extensive properties. Intensive or extensive. So intensive in the sense it does not depend on the amount of matter present. Amount of matter present. Extensive in the sense it does depend on the amount of matter present. Maybe you are cracking your brains. What is this intensive and what is this extensive? Doesn't depend on the amount of matter means what, and does depend on the amount of matter means what. Maybe you're cracking your brains, right? Okay, I will show you some of the pictures which shows the intensive properties, and then some of them possess the extensive properties. I will show you the pictures, then you can understand very clearly about what are intensive and what are extensive. Let's see then. See here, intensive properties. I told you it doesn't depend on the matter. That means boiling point. Boiling point that doesn't depend on it, isn't it? Doesn't depend on the amount of substance. It doesn't depend on the amount of substance. Boiling point of water is 100 degrees Celsius, whatever the amount of matter is. Whatever the, suppose if you have taken 1 kilogram, for that also it is boiling point is 100 degrees. And then if you have taken 100 kilograms, 100 kilograms of water or else 100 ml of water, that is also a quantity called as a boiling point is fixed. That is what 100 degrees Celsius. This is what the intensive property. It doesn't depend on the amount of matter. That means quantity of matter it doesn't depend on. Now coming to the color of the substance. Suppose if we have taken color, like a small quantity of color we have taken, that will show one color, and bigger quantity if you have taken, that show another color, or what? No, right? So whatever it is, the color is the same. Means it doesn't depend on the quantity. That means amount of matter. It doesn't depend on the amount of matter. Now come, that's what temperature. Of course, I told you the example for the boiling point, right? So temperature is also one of the intensive property. And coming to the lustrous. Lustrous, that means what? Lustrous, brittle. Okay, that means shines so brightly. Shining also doesn't depend on. Suppose diamond is only a smaller in size. It doesn't shine or what? Not like that, right? So whatever the size of it is, it used to shine brightly. Now coming to the hardness. Suppose iron, the small piece of iron is having smoothness and the larger piece of iron is having the hardness or what? No, hardness is also doesn't depend on the amount of substance. These all the types of substances, that means these are all the qualities are considered as intensive properties. These are all the qualities are considered as intensive properties. Now coming to the extensive properties. Yes, it does depend on the amount of substance. Volume. Suppose a small object has been taken, its volume is different from the next, isn't it? Now mass will be different for each of the substances. Then coming to the size over there. Coming to the size. What do you mean by size? Size also varies from object to object. Okay, now coming to the weight. Of course, mass is changing in the sense, of course, the weight is also changing. Weight also changes from the on the earth to the moon even, isn't it? Now coming to the length. Length of the object also differs. Means the one which does not differ according to the quantity of the substance, that is what intensive property. It depends on the quantity of the substance, that is what the extensive property, children. Extensive property. Maybe you understood what are the intensive and extensive properties. That is what we have three things, right? Three things the matter has been classified into. What are the three things? Properties and then state. Okay, so in all the three we have discussed now the intensive and the extensive properties. Okay, now let's see the properties based on even these properties based on even physical and chemical. Let us see. Physical. Observed without changing the composition of the substance. Observed without changing in the composition of the substance. See here the composition. We are talking about the composition. There is no change in the composition of the substance. And then we have observed that change. Of course, there is a change. But the composition doesn't change. Chemical change in the sense the ability of a substance to undergo a specific chemical change. Children, you need not worry about it because you are of class 7th. You have already learned the changes around us. Changes around us in your class 6th. Am I right? Or else you do one thing. If you want any clarity from this physical changes and the chemical changes and the changes around us, I have posted one video for class 6. That is what changes around us video. Okay, so you just do watch it, then you can get a clarity about the changes. Okay, clarity about the changes over there. Changes around us, how does it occurs and what types of changes which are called as desirable, undesirable, physical and chemical changes. These are all the changes I have discussed there itself. Here, okay, anyhow, we will discuss here also physical changes. Observe without changing the composition of the substance in the sense. For example, let us take an ice cube. Ice cube has been converted into water, suppose. Ice cube has been converted into water. Can that water can be converted into ice again? Yeah, of course. Okay, that means there is a appearance is different. Of course, ice in the sense we used to write the formula as H2O. Again, water in the sense again we used to write the formula as H2O itself. Okay, H2O in the solidified form in the ice, H2O in the liquid format in the yes. So water. So that's what we can easily say that this is a type of physical change. Suppose there is a chemical change. Okay, chemical change. Okay, let's take an example. Burning of paper. Let us take a burning of paper. If what happens whenever the paper used to burn, after burning, it used to turn into ash, right? Can we get that ash back to the paper? No, not yet. That means it is going to give us a new product. Okay, after chemical reaction, these are going to give us a new product. Those types of changes are considered as the chemical changes. Here, whenever water changes to ice, it is not going to give us a new product. It's not new. Water is changing its form. That's all. That is what transformation. Okay, right? That is what considered as a physical change. Maybe you got a clarity now. Clear? Now let's observe the next one. Examples of the physical properties. So physical properties, suppose there is a change in the color, change in the smell, change in the hardness, density, melting point, boiling point, state, solubility. These are all called as a physical properties of the substance. That means the ones which we can see, the ones which we can see with our naked eye, those are considered as the physical properties. Color, if there is a color change in the substance, we can observe. If the smell change in the substance, we can observe. Hardness and smoothness also we can observe. Density density, yesterday in the previous video I explained you what is exactly the density, right? So density also we can observe. And then melting point and the boiling points using the temperature notations also we can observe. And then state of the substance, either it is a solid or a liquid or it has been converted, also we can observe. Am I right? So solubility, whether it is going to soluble in other substances or not. These are all the things we can observe with our eye itself, children, with our eye itself. So these are considered as the physical properties. Okay, let's see the physical properties, how these looks like. How these physical properties looks like, let us see. So oxygen. Suppose oxygen is having a state called gas and it is the colorless one. It is having a melting point as -218 and the boiling point is -183 and density will be mentioned in gram per cubic centimeters, that is what 0.0014. Okay, now coming to the liquid, that is mercury. The state of the mercury is in the liquid state. What's its color? Silvery white in color, and it is having the melting point as -39 and the boiling point as 357 degrees Celsius and density is 13.5 gram per cubic centimeters. Now coming to the bromine Br2, this is also a liquid. It is in the red brown color, that means reddish brown in color. So it is having the melting point of -7 degrees Celsius and the boiling point is 59 degrees Celsius and the density is 3.12 gram per cubic centimeters. Maybe you are thinking that, ma'am, we have to note it down all the things and we have to remember. No, it's just for your information I'm giving you. That means the substance, whenever the substance is going to be changed, its formula is changing, and then the state, that means what we can observe from outside, means with our eyes what we can see. I'm discussing those. So let us suppose a water. The formula of water is H2O and it is in the form of a liquid, we can see. And what is its color? It is just exactly colorless. So its melting point is 0 degrees Celsius and its boiling point is 100 degrees Celsius and its density is 1 gram per cubic centimeter. This one we know most of the thing. And coming to the last but not the least, that is sodium chloride. Sodium chloride is a solid. That is what the common salt, children, whatever we are using. Salt. Mommy, it is tasteless. Salt I need. Okay, right? That salt it is. Okay, it is in the solid state, of course, white in color, and it is having the melting point of 801 melting point. It is means it has to convert into water without adding any water. If we continuously giving us heat, it's going to convert into liquid format at the stage of 801 degrees Celsius. Its boiling point is 1413. It should convert into vaporization state at the temperature of 1413 degrees Celsius. And its density is 2.17 gram per cubic centimeters. See, this type of salt we are using exactly. Okay, fine. Now let's see. States of matter. What are the states of matter? We have discussed the properties now. We have discussed the properties of matter. It's finished. Now let's discuss about the states of matter now. States of matter. What are the states of matter? Solid. That solid is having a fixed shape and volume and it is incompressible. What are the characteristics of the solid, children? It is having a fixed shape. It is having a fixed shape and a fixed volume also. Fixed shape and fixed volume, and it is even incompressible. We are not going to compress more and more. We are not going to compress it more and more. Okay. So this is what the next state of matter, it is liquid. So liquid, what type of shape it used to consider? Is it having a fixed shape? Fixed shape, children. It has fixed volume, but it takes the shape of its container. Is it compressible or not? Moderately compressible. It is not much. It is not much, but can compressible, but moderately. Not even high compressible. It is not even having less compressibility. It is having the moderate compressibility. So now coming to the other state of matter, that is gas. It takes the volume and shape of its container. Both are not fixed. Even the shape is not fixed and even the volume is not fixed. Is it compressible more? Yes, it is highly compressible. Okay, gas is highly compressible. These are the characteristics of the solid state, liquid state and the gaseous state of the substances. Okay, so solid particles are tightly packed. That's what it is, having a fixed shape, and liquids are somewhat loosely packed. I have given you, I hope so, before the characteristics of it. So after having the review of all these concepts only, we can get back to the next content. That's what I'm going to give you a clarity about it. Okay, children. So it takes the volume and the shape of its container. Now, states of matter, how it see. Suppose if we have kept a wooden box, wooden substance, which is in a solid shape, it holds a shape. Whatever the place we keep, it used to holds its shape. That means it is having a fixed volume even. It is having some length and then breadth and then height over here. Okay. Now, if a liquid has been poured into this, then what happens? It takes the shape of the container. Okay, it has a free surface also. It has a free surface and then fixed volume. And see, gas, I have filled with a small amount of gas itself, but it has occupied the total container. It has occupied the total container. Okay, this has been given actually from the NASA. That's what I have taken a picture to make you understand. Now, see how the particles are moving inside the substance. Even in the solid also, the particles used to vibrate from their mean position. See, children, observe it carefully. Maybe at the fixed positions, in the sense, of course, those are all fixed together, but they used to vibrate at the mean positions. They used to vibrate. Okay, and the liquid particles somewhat moving randomly. The liquid particles are somewhat moving randomly over here. And then gaseous particles, see, children, in this fixed area, there are only few gaseous particles are there. So you can understand this, why the gas has been filled up, has been taken most of the space. Most of the space. Okay. Now let's suppose here in the bromine. Here this is the bromine in the liquid format, children. Here the bromine is in the gaseous format, that is in the vapor format. Okay, so that's what liquid particles are moving randomly like this, and then after converting into gas, see bromine, the two molecule, right? That's what it is. It is bonded with two. That's what two molecules are moving here and there. Okay, so that means the gaseous particles are moving very randomly, very randomly. So this is what the arrangement of the particles inside the substance. Okay, so it means solid is having tightly packed and liquid having somewhat loosely packed, and gaseous are very free enough. Now coming to the change of phase. Change of phase. These are all we discussed, children. That's what I'm just giving you a brief description about all these things. Brief description. Melting. Melting in the sense what, children? A solid substance has been converting into liquid, then that will be considered as a process called melting. Okay, change of the phase difference it is. Now condensation means these are the solid to liquid, liquid to gas. These are just the states of matter, right? So one state of matter to the other state of matter, if it is changing, that is what considered as a change of phase. So coming to the melting, so solid is converting into liquid and then that is called as melting. Now suppose the gas has been converted into liquid, then what happens? That is, yes, that is a process called condensation. Now, if the liquid has been converted to solid, then that is freezing point. That is freezing. Process is freezing. Now, evaporation is nothing but liquid to gas. That means a substance of a liquid substance has been converted into gas, then that will be considered as evaporation. Now, if a solid substance has been converted into gas, then what it is called as sublimation. For better example for this sublimation is what? Camphor. Karpuram, what we used to do for our pujas or something else. So it is going to convert completely into gas by giving out of a flame. Okay, solid is converting into gas. So evaporation, coming to the boiling, evaporation occurring beneath the liquid's surface. Evaporation occurring beneath the liquid's surface. That means the total liquid will be converted. The total liquid will be converted into vapor. Okay, the total liquid is going to convert into vapor. That means all the substance will come into the same temperature level. That is what 100 degrees Celsius, suppose water if we take. Okay, so this is what considered as boiling. Okay, now is changing phase a physical change or a chemical change? Changing of the phase, I have given you so many examples like melting process, freezing process, and then condensation. Are these physical changes or chemical changes, children? Are these physical changes or chemical changes? These are the phase differences can be reversible, right? If we can reverse them, that means change of state only. There is no composition of matter has been changed. Suppose a gas like suppose water vapor has been converted into water. Of course, water vapor also H2O and water is also H2O. That means you can change it, say that it is a physical change. Am I right? Let us observe some of the changes, children. Tell which type of changes are these. Growing of a plant from a seed. Growing of a plant from a seed. What type of change is this, children? What type of change is this? Is it a physical change or chemical change? Definitely it's a chemical change, because seed proteins and plant proteins are different. A slightly difference will be there. A new product. Seed is different from a plant, right? So that's what, from the seed plant has been arised. A new product has been arised. That's what it is, a chemical change. Now, evaporation of water. Evaporation of water is a physical change or a chemical change, children? Is it a physical or a chemical change? Simply, it is a physical change, because evaporation of water, water is converting into vapor. In the sense, both are water forms itself. That's what it is, H2O and H2O itself. That's what it is, a physical change. Now, occurring of tides in the sea. Occurring of tides in the sea. Is it a physical change or the chemical change? After occurring the tides again, that is just water, right? That is only water. Tides in the sense, of course, the sea water only. That's what it is, a physical change. Now, revolving of earth around the sun. We cannot say that it is either a physical change or a chemical change, because while it is revolving around, we can simply say that it is a periodic change. It is a periodic change. That means it repeats. The action will repeat after a particular interval of time, again and again. Am I right? To understand better about the physical and the chemical changes and what type of desirable and undesirable and man-made and natural are that, and what type of this periodic and non-periodic changes, if you do watch the previous video of your class 6, okay, I have posted even that too. Okay, you just watch that video also, you can understand better about it. Okay, children. So, which type of change? Growing of a plant from a seed, evaporation of water, occurring of tides in the sea, revolving of the earth around the sun. Right? That's all for today, children. This is our end of the show. Now it's your practice time. Okay. Try to observe most of the changes what are around you. Tomorrow we will start our session with the classification of matter. Okay. In this session itself we have started. It will take some more time. That's what, half an hour to 40 minutes it will take. That's what I will, and that should have a continuation. Okay, so that's what, I'm not going to waste your time much, right, children? Thank you so much. Meet you in the next class. Bye bye. Take care.